All right, so we're starting working on translating real world context problems into an equation in order to solve given a context problem. So that's what we're going to be doing these next couple days in class. So a big skill within that is going to be what we call defining the variable. So that's what we're going to start with in our notes. So notice the directions are simple. It just says define the variable. Notice it doesn't say solve the problem, it says just define the variable for these starting ones. Okay. So if we looked at number one, it says you have a storage rack that holds 40 CDs. You have 27 CDs. How many more CDs can the rack hold? Okay, so for our notes, define the variable. That's saying identify what you don't know. We want to identify what we don't know. That's the variable. That's what we're trying to solve for, right? A variable is like X or any letter you use for that. Variable is what you don't know in the problem. Okay, so what you want to do is look for the question. Look for the question. Okay, so our question at the end said, how many more CDs can the rack hold? And now we just quantify that and put in words what the variable represents. Okay, so we're going to write X, our variable, equals or represents, in this case, the question said how many more CDs can the rack hold? So we would say the number of CDs. Okay, if we were going to solve this problem, we would need X to represent a number of CDs. Okay, and then you would set up an equation and solve for that number of CDs. Okay, so we're starting by just reading through word problems and identifying our variable, practicing writing it out. Okay, so 2, it says you are taking part in a charity walk and you've walked 12.5 miles so far. Your goal is to walk 20 miles. How many more miles do you need to walk to meet your goal? Okay, so again, we read through the problem, we identify what is our variable from looking at the question itself. Okay, so the question said, how many more miles do you need to walk to meet your goal? So we're going to name a variable, define our variable, we'd say X equals, the question said, how many more miles do you need to walk? Okay, so X would represent a number of miles walked. Okay. 3 says you are baking batches of cookies for a bake sale. Each batch takes 2.5 cups of flour. You have 18 cups of flour. How many batches of cookies can you make? Okay, so again, we read through, we identify that question part. Variable always comes from the question part. Okay, so it says how many batches of cookies can you make? So X would represent number of batches of cookies. Okay. Again, there's good variety in these problems, lots of different types. Look at 4, you pay $7.50 for 3 quarts of strawberries. How much does each quart of strawberries cost? So we go to the question. X represents, well, how much does each quart of strawberries cost? So we would say the cost of, notice it said each, or 1 quart of strawberries. Right, we don't want to say the cost of all the quarts of strawberries, just one of them, because it said how much does each quart cost. Okay. 5, you make dog collars to sell at a craft fair. You spend $85 for materials and hope to make a profit of 90. How much should you charge for each collar? Okay, so how much should you charge for each collar? Well, if we're thinking about how much we're charging, why don't we call that a price? So the price of, again, it said each, so one collar. X will represent the price of one collar. All right, we just did 5 together, so let's start trying some on our own. So read through number 6 and then type in what you would say the variable represents. Okay, so it says you have $70 to buy a mountain board that costs $250. You plan to save $10 each week. How many weeks will it take to save for the mountain board? Okay, so you see that he said the M was important there, so we say X equals the number of weeks. Right, X is representing the number of weeks that pass where we're saving for our mountain board. All right, why don't you guys try number 7? Okay, so one car travels about 28.5 miles on each gallon of gas. Suppose the average price of gas is $3 per gallon. So about how much would the gas for a 978-mile trip cost? One's tricky, so think about how to put that in words. It's about how much would the gas for the whole 978-mile trip cost? Okay, so X will represent cost total for gas on trip. It's the cost, the total cost for gas. Okay. 8, why don't you guys try that one? Okay, so you have saved $100 and plan to save $20 each month. How many months will it take you to save $500? It's a little more straightforward. How many months will it take you to save $500? X will represent the number of months. Okay, you could be more specific and say number of months of saving, but it means the same thing to say X equals the number of months. Okay, so that's defining the variable. We're just going to do a couple of our context problems, and we'll do a couple simple ones, and then starting tomorrow, we'll get into our more complicated real-world context problems. Okay, so we'll finish up today with just a couple short, simpler solving ones where it's just translating a sentence into an equation, and we'll stop there. Okay, so 9. So notice our directions. It says define the variable. That's what we did on the first page. Then convert the statement into an equation, and then solve. So 3 steps. So we have to define what the variable is, write out an equation, solve the equation to answer the problem. Okay, so we looked at 9. It says 17 subtracted from a number is 12. Okay, so what I don't know, we want to identify the variable. So this one's a little different than the previous page. So we have to think about what don't we know in this problem. So it says 17 subtracted from a number is 12. We're going to use X for our variable. Well, here, all we really don't know in this is that number. Okay, so X equals the number. Right, well, we don't know. Okay. We have to be careful when we write the equation for this one. This is a tricky one. So it says 17 subtracted from a number. Okay, so we're taking our number and subtracting 17 from that. Okay, so our number, remember that's really what we're calling our X. So we take our X and we want to subtract 17 from that. So X minus 17 equals 12. Okay, and now this is just a quick solving one in order to get our solution. Okay, so notice this is an equation that we can solve for X. So X minus 17 Well, to undo that, we would add 17 on both sides. So 12 plus 17, 29. Okay, so x equals 29, or you could say 29 is the number. I'm just writing that because later on when we do our real world context problems, we're going to have to communicate our answers at the end. Okay, this one is more straightforward because x just represented a number, but later on we're going to have to answer problems. Okay, 10. So it says 6 times the number increased by 9 is 82. Okay, so we think about what we don't know in here. So 6 times a number, same deal. Okay, x equals the number, right? The number that we don't know. Okay, so it says 6 times a number, so 6x increased by 9 plus 9 is 82 equals 82. Okay, and now we solve for x. So let's subtract 9 on both sides. So 6x equals 73. Divide both sides by 6. Okay, so this one doesn't come out perfect. We do 73 divided by 6. Get like 12.16 repeating. Okay, so our solution, say x equals 12.16 repeating. 12.16 repeating is the number. Okay, so we're going to stop there, and we'll get into the tougher real world context problems starting in our long period tomorrow.